Hi, this is Mrs. Miles recording another higher GCSE revision question. This one is near the end of the paper, not quite at the end, but still is a star grade. If you're doing this topic by topic, it's a non-calculator paper, and the topic is transformations, in particular enlargements with negative scale factors. Enlargements, negative scale factor. Now, the first thing I want you to think of is when you see the word enlargement, you think, right, getting bigger. Okay, it's fair enough. That's what most people would think. But when you see this fraction, just think, right, okay, I'm enlarging it, but I'm making it half the size. So it's going to get smaller. And this is just so you check it's sensible. But then you see this here, and you think, oh, no. Okay, because what a negative enlargement means, it doesn't just get half the size, it actually inverts, it flips over. And if you want an idea, and this is how I imagine it, mine, this is how old I am as well. If you Google negatives, or you ask somebody at home that's older than you, and my age or older, which is obviously very young, then you can ask them how we used to get our photos. Used to come, as well as being developed photos before the digital age, you used to get negatives. And the negative was like a little brown strip, and everything that in real life looked light looked dark on the negative, and everything that was dark looked light. So it's like complete opposite of what you'd expect. And this is how I remember this, that this is like an inversion, it flips over. So we're talking about movements. This is the important bit. Center 0, -2. Notice the switch. So 0, -2. Now for goodness sake, do not put it in there, which is a common mistake. So there's my centre of enlargement, and that's very important. Now, if I taught you last year, you can use coloured pens. Excuse me, moving around my coloured pens. But when you actually do it in the exam, it's probably wise to then go over it in pencil, okay? Because some of this stuff might show up. What I'm going to do is to do a little green bobble there, okay? And I'll first of all describe how I get from the centre to there. So I've got to go across 2, up 4. Now, the reason you're thinking, you're supposed to be a maths teacher, you're doing your coordinates all wrong. This is what we call a vector, so it describes a movement. So it's actually going across 2, up 4, always the across bit first. Okay, so positive because it's going up, across 4 because, sorry, to the right, 4 because it's positive 4 because it's going up, not down. So in this one here, to get from there to there, everything is moving across 2 and then up 4. If it's going to be half the size, it will go across 1, up 2. And that would be what we would normally do if it's half the size. But because this negative, it's going to go back 1 and then down 2. It's going to go the opposite. So we start back here. So to get from here to here, we went across 2, up 4. Half that would be across 1, up 2, but we're doing the opposite direction. So we go back 1 and then down 2. In fact, a little bubble instead. Green bubble. Now, what some people do, and it's not wrong at all, but it's not the way that I taught you lot, is that once they've got that vector there, they multiply it by -1/2. So they halve that and then make it negative, so you get -1. They halve that because you times it and make it a negative, so they write -2. And you can see then there's where my 1 back, 2 down comes from, okay? So that's not wrong, it's just not how I've done it. Let me just move that over so you can see it a bit better. Okay, so now I'll pick a different colour. I'm going to go for orange. So we're back to the centre. So to get from there to there, I'll go across 2, and then I've got to go up 2, 4, 6. So if I write this bit in orange, so I've had to go across 2, up 6. Across 2, up 6. If you want to put the positives on to remind you, you can. Now, it's getting half the size. So divide that by 2, it will go across 1, up 3. Then I've got to remember it's negative, so I'm going to go backwards. So from here, I go back 1 and then down 3. Now, straight away, I should be thinking, yes, that's good. Because look at the gap there. It's a gap of 2, and this is a gap of 1. So it's got half the size. Okay, notice how it's inverted, it's flipped over. I've got 1 left to go. Now, some of you can work out where this actually belongs, but in case you can't, okay, let's do it properly. So I'm going to go back to my trusty pencil, because I can't find another nice pencil in there. So again, always from the centre. So I'll go across 2, 4, 6, and then up 2, 4, 5. Now, the reason I'm checking that, and it is always a good idea to check, is normally, because I'm going to be halving this, I thought, well, maybe I made a mistake there, but it is across, what have I put across to? 2, 4, 6, across 6, and then up 5. So everything's getting half the size. So divide this bit by 2, so I'd get 3 and then 2.5, but it's going backwards, so I go back to my centre. So I'm going to go back 3, 1, 2, 3, and then I'm going to go down 2.5. So 1, 2.5. Join it up. If you think it's not going to be seen very well, shade it in. But if you notice, it's half the size and it's inverted. Let's check you've done it right. Draw our rays. So green goes to green. Some people use a dotted line here. Orange goes to orange. And then grey goes to grey. And if you notice, if you've done it right, all of these rays should converge in the centre of enlargement, which they do. Anyway, I hope that helps. Apologies that it keeps slipping off the page. And I'll be recording again tomorrow. So I hope you're all revising. I hope you're all well. I miss you guys. And I'll be back soon. Take care. Bye bye.